Welcome. All right. Thank you. Looks like I almost got everybody here. Oh my gosh. Welcome back. Hopefully you guys had a good day off yesterday from this class. Or were some of you guys, man, I missed having stats class. It's okay. I understand. You don't have to be like that. Any other questions from homework before we get back into where we left off?
One more.
Sure.
How would we, I have to click continue. How would we calculate the average of the 36 taxpayers? I'm confused on the formulas.
No, stop. Didn't they give you the average?
They gave us the average taxpayer, but not the average.
Good, yes, I know. But again, I really want this to make sense. If I knew the average amount of time it took each person in here to complete a tax form, right? That would not change just if I took two people's times at a time and got the average of those averages. Why would the overall average change? Does that make any sense? No. We saw it happen on that one sheet with all the colors on it. I think there's two colors, but for me it's a lot. No. So there's an average age in this class.
Mm-hmm.
And how do I calculate it? I take one person at a time, add them up, divide by how many, right?
Right.
What if instead I took every group of two I could, and then I averaged up all the averages from every group of two? Why would it end up being higher or lower than the average of everybody? It would be exactly the same. No? Does that not make sense?
Well, because the group of two could be me, like I'm 35.
Listen, stop. Every group of two. So you could say the same thing about one person. Well, that one person could be me, or, do you understand? I'm 48. That one person could be me. Because I'm taking every person to make the average. And if I took every group of two people to make the average, I'm still including everybody, am I not?
True. Okay.
So the average would stay the same. So that's the thing the central limit theorem says. If you take a sample, the mean of the sample means is the same, but the standard deviation gets smaller because now it's less likely for something to be really far away from the mean. You expect a sample to be closer to the mean.
Got you. Okay, thank you.
You're welcome. All right. How's everybody else? You guys good? I think somebody else just came in. Any other questions?
Oh, me, I have one.
Yes.
On the 7.2, on the 96.
96.
I know I'm doing something wrong because I do one time and give me some number, and the second one give me another number, and the third one give me another number. So I know I'm doing something like it's not making sense.
I got you. And by the way, I think at some point they had an example. IQ scores are known to be normally distributed in case, especially the person I was talking to earlier, this is only 20, right? The sample size is only 20, but it's okay because they're already normally distributed. That's one thing I want you guys to realize. But what did you do first on this problem? What did you do first? Samantha?
I just use the formula, so I think maybe that's
Which formula? Sorry?
Let me see.
So they give me the average, the mean, right? So the mean is 105, and they give me the standard deviation of 20. And this, of course, is the standard deviation for individual adults. But the question they asked me is related to groups of 20, right? So what's the very first thing I should do? Anybody?
Change the standard deviation.
Yeah, yeah. I can't answer this question about sample means unless I know the spread of all the groups of 20, unless I know the spread of all the sample means. So 25 origin. It's one of my favorite sounds. Oh, I get it now. All right.
Okay, I know what I'm doing wrong.
Yeah, so that's 96. 96 is a chapter 7 problem, and I will remind you, we talked about this one before. This is more like a chapter 6 problem that looks like a chapter 7 problem.
Okay,
And I know
perfect.
it's sitting in chapter 7, and I don't care. That's how math works. Anything we learned before can come up anytime it wants to. But they do it specifically to make sure you understand what are the two things you need to see before you change the standard deviation. What are the two things that tell you you need to do this, that you need to change the standard deviation? What two things? I have to take. Well, let's be more specific. What is it in this problem here that told you you had to change the standard deviation?
Mean.
No. So the mean is the mean. That doesn't tell me anything. What told me I have to do this? There's two things. One is you got to take a sample. Does that make sense? So then n is something, right? Anybody with me? Are you guys remembering this? No? Have you forgotten everything? You guys with me out there? What's happening today? And then they ask a question about the sample mean. So let me say this again. I really try to make a point of this when we first went over this. Well, how do I know when to do this? When to change the standard deviation? When they take a sample and they ask about the sample mean. Because now I need a picture that is how sample means are distributed, not how individuals are distributed. So the original standard deviation they give me won't help me. I need the one that works for groups of 20, which is what this finds. I really want that to make sense. As always. You're like, whatever, dude, just tell me what to do, when to do it. Just do it. Okay, all right. I don't know. Does that help? Does that hurt? Is that you're in the same place?
No, that's okay now.
You sure? Okay. Yeah. Whenever I ask that kind of question, your answer could definitely be, I still have no idea what you're talking about, dude. Maybe not that pointed. Try again, math boy. I mean, that's probably not going to get you anywhere if you do that. Try that again, math boy. All right. That's my name for myself. You might know what to call me. I'll go. Yeah, you can call me that. Okay. Anything else before we get back into finishing up this sheet from last time? Here we go. Let me put this up here while you guys think. So last time we did this dolphin problem. Right? And I sort of looked at part B. And so what I want you to do, oh shit, I want you to do part B. Just do part B. Just figure out the 90% confidence interval. This will be a nice review since it's been a little while. So there's the mean and the standard deviation up here, right? So what's the main thing? What's the only thing that's going to change in part be compared to what we did last time for part A?
The z-score?
Yeah, because up here I wanted to be 95% confident, so I had to go out this far to catch that much. Now I want to just be 90% confident, so I'm not going to have to go out as far. Now, does anyone remember how to get this? And then I'm going to show you a shortcut, because that's how math people are. Do it the hard way, and then I'll show you a shortcut. So here's the 90% confidence interval. How do I figure out these z-scores down here? Oh, I should open up.
Look them up.
Look what up, though?
Look up the area.
What area?
0.9.
Nope, 0.9 won't help me, because again, when you look up an area, the chart thinks that's an area below a z-score that you want. That is not true. That is the area between. Can you give me one area that's? I'm sorry. Go ahead.
Oh, sorry. I just said, would it be 0.05 on each side?
Yes. If there's 90% inside, there must be 0.05 on either side. So right there, can I get that negative z? Can I get that lower z? Yeah.
Yes.
What would I look up? The 0.05, Jeff. The things she just said. Yeah, you're right. You're right. Because now that is an area below. I really want this to make. I know I keep saying that, but the chart only understands areas that are below a z-score you want, or a z-score that you know. In this case, I want to know that z-score. Well, what area is below it? That's the only way the chart can help me, is if I know what area is below it. So what do you get when you look up 0.05? You should get something semi-freaky.
Negative 1.645.
Beautiful. Because, I don't know, can you see the z-score chart now, if I do that? Yes, okay. So right here, it's between 0.0505 and 0.0495. So if I follow this down, I get 1.645.
Real quick, can I ask why we use the negative z-score? I forgot.
Oh,
I missed that part.
Here, you tell me. I'm trying to find this z-score, and it is below the mean. So
could you not use the one on the right?
Sure, but then what area would I want to look up?
Oh, you have to look up below, so it makes more sense to look up. Okay, because it always goes to the left.
You could, but it's just quicker, you know, I already know the 0.05, so I might as well find the negative one. And then the positive one is just take the negative off, right? That's the beautiful thing about the symmetry. Now, so we get 1.645. Does everybody understand that? Anybody not get that 1.645? Speak now or hold your peace for a little while.
Yeah, I didn't get that. It was negative 0.05 that we're looking at?
No, definitely not.
Or
just 0.05, 5%. If there's 90% in here, there's 5% on either side, right? So 0.05. So looking at 0.05, I get right between these two things.
Oh, you're just looking. Okay, I was looking at it in the column, but that's different. Okay.
That's not a z-score. I want to find a z-score. Z-scores live out here. If I don't know them, I can't look out here.
Yep, and the inside is the probability. We're good.
Exactly. Now, let me show you a shortcut. This is what I call the baby chart. You ready for the baby chart? Don't start singing. Baby chart. No, all right, sorry. Now I'm sorry. I just had to share it because it went in my head. So I'm gonna. You're there with me now. Our own little hell. If you don't know what that is reference to, I feel jealous in a way. All right. Here's the little baby chart, right? And this, of course, is mama chart. Now, here's baby chart. Look at the confidence level. Look at 90% confidence level. You guys see that? What z-score is there? They call it a critical value. You're just being stupid. It's the z-score. 1.645. Isn't that what we just got? So that little tiny baby chart only works in this specific way, right? If I wanted a 90, 95, or 99. 95, haven't we gotten 1.96 before? Do you guys remember that number? And if I want to be 99% confident, well, shit, little Mr. Overachiever, then you have to use this crazy ass z-score. I don't know if you guys can even see that poor little thing. Okay, coming back. So now you can use that little shortcut. We're actually going to get an even better shortcut today. We'll see if you agree with me or not. So we know that the X bar was...
Which handout is this? I just want to bring it up in Canvas on my own.
Yeah, it's the one that's in chapter 8. Hold on. I think it's the only one that's available in chapter 8 at the moment. Unit 8, right? If you go to Unit 8, it says section 8183 handout, right? You got it? You got it?
Unit 8 isn't open for me.
Of course it is. You went too far. Unit 8, not turn in chapter 8. Unit 8, confidence intervals.
Okay.
Yeah, yeah.
Unit 8, section 8.1, 8.3 handbook.
Yeah, that's the one.
All right. Going on down.
Okay.
Got it.
And let's see. So the mean was 92.6, and the standard deviation is 4.11. So if you haven't done this yet, and the n was, what was the n? 37. So now you got everything you need. Go ahead and do that formula if you haven't done it yet. Oh man, I still haven't fixed my calculator. Scheisse. Oh, let's see. Did anybody get the error yet?
I get 1.11.
Kick ass. All right.
How far are we rounding?
So the rule of thumb here
Mhm.
is you go out one more decimal place than the mean for the error. Do you see that? You go one more place.
Oh, for the error. Okay.
Yep. Let's see. So I get 91.49 up to 93.71. Is that cool? Can you write the conclusion?
How do you get the error again?
Oh, the error is just this piece. Just throw this in the calculator. So it's 92.6 plus or minus shit. So if we can figure out what that shit is, then I can add and subtract it. Does that make sense out there? Just this piece. This piece of the formula, that's the error.
Oh shit, I did it wrong. That's why. Never mind.
Well, she can say shit. I can say shit. You can say shit. Somebody
I was
reacted.
adding it instead of multiplying it. I was like, why am I getting a bigger number?
There you go. That'll do it. Is everybody okay out there? Do you guys get those numbers? All right. And then the conclusion. It's not done until you've written a conclusion. Right? We are 90% confident that what?
The true mean falls within the interval.
No. Sorry, you got one little tiny, it seems like a little tiny thing, but it's huge.
You're 90% confident that the average length.
No. You're like, what does this guy want? What does this jackass want from me?
True population mean?
No. We are 90% confident that the interval we created contains the true mean. So it's the true mean is sitting somewhere. If we say we're 90% confident that the true mean falls in our interval, it's as if the mean doesn't exist until we make the interval. I know this sounds like a nitpicky point. I don't care. It isn't. It's a fundamental idea here. We are 90% confident that the interval, what is it? 91.49 inches to 93.71 inches contains the true mean length, or you can say it contains the population, however you want to say it, the true mean length of dolphins, blah, blah, blah. Okay, there you go. Blah, 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 blah. So you guys can pretend like you can read that. So I'll say it again. We are 90% confident that the interval 91.49 inches to 93.71 inches contains the true mean length of dolphins in that area, however you want to finish that off. Okay.
Whew.
Exactly.
Yeah.
That's right.
So you need to have the interval first before the information about the question?
Yes. Because the mean exists. We are, so it's sort of like if we blindly swing a net, right? We would say, and there's a butterfly somewhere, we swing a net, we would say, I am such and so confident that my net caught this butterfly, right? I don't know how to explain this better, but it's not that we hold the net and we wait for the butterfly to fly into it. I don't even know if you guys are with me anymore. You're all like, this guy's talking about freaking butterflies and nets. I think that's what he needs. He needs to be in a net. This guy needs help. Put him in a hospital. Listen to him. Sorry. I'm tired. I know it doesn't sound different, but the interval is what could change. If another group came along and got another sample of dolphins, would their interval end up being the same as ours? Do you think that if another group came along and took another 37 dolphins, a different sample of dolphins, do you think that their interval would end up looking like ours? What do you think? So another way to answer that, another way to think about that question is, do you think another group with a different sample would get the same mean we did?
No.
So their center would be in a different place. Do you guys understand what I mean by that? Can somebody tell me what the middle of this interval is? What's the middle of this interval? What's right in the middle of it?
92.6.
Of course 92.6, because we added to it and subtracted from it. So if a different group came along, I will bet you a lot of money that they would get a different average, right? So their interval would sit somewhere else. And then they would say they're 90% confident that their interval catches the real mean. All right.
Because there's a 10% margin of error.
Yeah, there's a 10% chance that neither one of us caught the real mean. Yeah.
Got it.
All right.
All right. What does E mean in this next bonanza?
I like that. So can somebody tell me again what did I call this part?
The air?
So that's E. All right, so let's start there. So we're gonna prove this formula first, right? Ha ha ha. Doesn't that formula look freaky? So let's see, the error is this piece. And why does that make sense? Because that's what we plus and minus. That's how far off we think we are from the mean we got. Does that make sense? We get the mean, we go up so much, down so much, so that ends up being how far off we think we are. So the error is z sigma over the square root of n. How would I solve that for n? Here's a neat trick. You ready? All right, this is gonna seem really dumb. 10 divided by 5 is what? 2. 10 divided by 2 is what? 5. Can't these just switch places? Do you see how they just switch places? Of course, 10 divided by 1 chunk equals the other chunk. So what does this have to do with this weird ass looking thing, Jeff? Huh? Math boy. You said I could call you that. I did. Well, look here. These can just switch places. Isn't that good? Because doesn't it suck that the letter we're trying to solve for is underneath? That sucks. Well, let me bring it up. Let me just change places. And then what's the last thing I need to do to get n by itself? Square it. Yeah, then I square both sides. And then I end up with exactly what I've got here, right? So now, what good is this, Jeff? Well, if they ask me, how big of a sample do I need to have this much error? I can answer the question. Now, real quick, stay with. How big of a sample did we need to have an error of 1.11? You know this answer. How big of a sample ends up with an error of 1.11? I'm sorry. Let me change that. I forgot for a minute. I did not mean to do this, but this is 95% confidence, right? So let's go back up here. How big of a sample do I need to have an error of 1.32 at 95% confidence?
37.
So if a sample size of 37 gives me an error of 1.32, what do I want the error to be now here? 0.5. Do you guys see that? Within is a really good keyword for error. That's how much I want to be off by. Do I want to improve or make worse the error? I want to improve it, right? It was 1.32. Now I want to make it 0.5. I want to make it better. Don't you agree with me? That's better to have a smaller error. So should the answer for n be higher or lower than 37? What do you think it takes to make the error less? You know this from day one. What's better, a big sample or a small sample?
Big.
Big.
Small error.
Big sample leads to small error. That's right. So n, if I use this formula, let's identify everything. Z is 1.96. I really hope you guys are cool with this. Got to go back up to 95%, right? 1.96. Z is 1.96. X bar, I don't care. I'm remembering. Sigma was 4.11. E is 0.5. That's how much I want to be off by. So how do I know when to do this? When the problem says, how big of a sample, or how many would you need to sample, or how, whatever, the number, what's the number you need to be within? Okay, that I need to have a formula that's solved for n. So I can figure out what the hell n is. So now I can throw everything in there. N is 1.96. Let me do this a little bit different way than I have it written. Times 4.11 divided by 0.5. And then I just square everything at once. It's a little bit better than the way I wrote it. And we know it's going to be more than 37 because 37 gives me an error of 1.32. And I want to get that sucker all the way down to ½ an inch off. Is that right? No. Jeff?
Could you scroll up a little just for 1 second?
Yes. Which part are you looking at?
Part A, the 1.96. Okay.
Yep.
The 1.96, that was what we calculated. Because was the first, was 1A also talking about 95% confidence?
Yes. Yes.
Okay.
Cool.
Is it 260 dolphins?
Yes. Good. You get 259 point who cares? You round it up to 260 so you don't have to chop up any dolphins. And make sure you understand that's a up arrow, not a number.
Fucking you, dolphin. Fucking you, man. Sorry, South Park. You know the episode where the Japanese people are chasing down and killing all the whales?
All right. Let's not talk about that. Let's see. So does that make, I really want this to make sense. to decrease the error all the way down to half an inch, I got to get my sample up to 260. Because when it was only 37, then my error was kind of big. This is, well, it's not that bad to be honest. But if we want to get all the way down to half an inch error, I got to up my sample size to 260. That might be a big order to find 260 dolphins in this little area, right? So that might not be possible. How are you guys feeling out there? Like the same as they did last time we were together, dude. Confused?
It's starting to make more sense the more we do it.
That's the idea. All right, I like it. Now,
can we do another one? I've never thought I'd ask that, but
we can. I can make up another one real quick before we do this. This is a whole different section. So let's do one more.
Move on to the next section. Can we do one more of these?
Yes.
Thank you.
So I'm going to stop sharing. You guys ready? I'm going to stop sharing. All right. So now I'm going to have to erase my little spirit animal. Let's see. I like this. I'm wearing my semi-dressy shirt and my shorts. Yay! Oh, Zoom. Oh no, Mr. Bill. All right, so I can make a real quick example. Let's say that we sample. You guys see that? Yeah. We sample. It doesn't matter, Jeff. There it is. 52 people, and find an average weight of 182 pounds. Find the 99% confidence interval for the true mean weight of people in this area. For true mean, blah, 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 blah. Okay. Now, when we're done with chapter 8, we're going to have 3 confidence interval formulas. And they have very well-defined times to use them. Right now, we only have 1. So it's pretty easy. So if I say find the confidence interval, at the moment, I'm using this formula. Did I give you enough information? No. Let me give you one more piece of information. Sigma is known to be 10.13. Forgot some information. It's my fault. So what's the only thing that I didn't just give you?
The Z-score.
Z-score, yeah. Somebody remember how to use the baby chart? Sorry.
Yes.
We find the Z-score. So we know X bar is 182. We know sigma is 10.13. We know N is, where'd it go? 52. Now all we're missing is the Z-score.
Negative 3.49.
No.
Negative
You look-
2.575.
Yes, and no negative, right? All you care about is the number because the plus or minus is built in. I really want that understood. There's a positive one, there's a negative one. So nobody used the baby chart. That's okay. Is that all right? So I have to give you a lot of information. Right? So one of the main things you're not going to know is the Z-score. You got to look that up based on how confident I want to be. So if I want to be that damn confident, I got to go pretty far out. So I catch a lot of data. So I'm going to be that confident.
Oh, I have a question. So how did you get 2.575?
So there's 2 ways. It sounds like people were doing it this way, which is beautiful. Not a damn thing wrong with this. 0.99, right? 0.99%, so there's 98% inside. there must be 1% outside, which means there's 0.5%, 0.005. And if you look that up in the negative chart, you'll get negative 2.575. Or you look up a 99% confidence level in the little baby chart that I showed you. It's on the bottom of the positive side of the z-score chart, and it will give you 2.575. Does one of those two make sense?
Yes.
Okay. You need to do it exactly the way we're doing it, or now it's one of the ones that they give to you really quickly in that little tiny collection. And now it's just a throw in the calculator problem, right? What's the error? Like 3.88? It's a total guess.
I got 3.62.
That's fine. I don't know if you noticed, but I did what I said in my head. So that's 3.62. Sure. So in this case, just to point it out, you have to go at least one place out because this is 0 decimal places. Do you guys see that? So this has to be at least one place out. So 2 is fine.
3.6173.
Say again, sorry.
3.6173.
Okay. And again, this is 0 decimal places, so this has to be at least 1 decimal place. And she went out to 2
You
decimal.
want these scores in 2 decimal places. Got you. Thank you.
Yeah, because the chart needs them there. Yeah. So this will be 178.38. Is that right?
Yeah.
185.62. And then take a minute and see if you can write the conclusion.
Wait, it's 182 plus 3.62.
Yes.
I got 185.
So did
Oh, for the second one, I'm sorry, I got confused.
That's right. And then this one is 182 minus this. All right, let's see. The conclusion is we are
99% confident that the true mean falls between 178.
Nope.
At the interval,
Good.
178.
Yes. 0.38.
To 185. Oh, pounds.
To 185.62.
Contains the true mean weight of these people in this area. You can say population, that's what true kind of means, but true mean weight of the people in this area, blah, blah, blah. Okay.
Could you say true mean weight of sample? It contains the true mean weight.
Well, no.
Or no, it'd be of the whole population. Okay.
Has to be. The sample mean I know with a 100% confidence because I calculated it, right? So now I know. It's this population mean that I'm sort of like, it could be around here.
Okay, starting to make sense.
Sweet. All right.
We end it at contains the true mean weight, or is there more after that?
Well, all right. So in general, you want to say you got to be specific to the problem. So I sort of wasn't that specific, but I said contains the true mean weight of people in this area.
Oh, okay.
Took a sample of people from a certain area. So don't just say it contains the true mean weight and stop, because that's not telling me what you were analyzing. So you do have to come back to what the problem is about, right? Okay. So in case you get something like negative 20 up to 0.7, and when you write the true mean weight of people, hopefully you'll go, well, that can't be right, right? points at little tiny people. Hey, little person, how you doing? All right. Okay. Oh, so now let's talk about. I kind of want to leave this here. Why not, Jeff? You just want to flip this and see what's over here. Look at this. Do you remember that? That's from a long time ago, relatively. All right. So, do you guys remember? All right, so we are getting into section 8.3. If anyone's curious about section 8.2, we do that next because it introduces a whole new chart. So I don't want to do that yet. 8.3 still uses the z-score chart. That's why I like doing that next. Method to my madness sometimes. All right. Do you guys remember that we started with this formula? Do you guys remember that? That we started with that formula and then we kind of created the confidence interval formula from it? So what we're getting into in section 8.3 is creating confidence intervals for percentages. So somebody help me out. If I have a problem with a percentage that does something, so I have a percentage that doesn't do that thing, right? And I have a number of people or things. Are you guys with me? I've got an NPQ problem. We're gonna start at this position and build into the formula for percentages in the same way. So what is the mean in this situation?
In which situation? On the handout?
In this situation, what's the mean?
Q divided by 2?
No.
Is it like half of it? Half of it? I don't know.
No.
Isn't it just, I think it was P and N?
N times P, yeah.
Oh.
And what's the standard deviation? Anybody remember? I'll start off.
NPQ.
Yes. Now, here's the thing. All right. So the same way that we used it to create a way to expand on a sample mean, right? If we have a sample mean, I can then adjust it to make it better. And this is where we did this business. All right. Right. So I really want you guys with me on this. So it's a lot of different kind of, and let me see if you guys are cool with this. Doesn't this, what is this supposed to do? Let me see if you guys can answer this question. What is that interval supposed to do? I'm supposed to be such and so confident that that interval does what?
Falls within the given.
No. I want to be such and so confident that this interval does
contains the true mean.
Contains a true mean. I love it. So let me see if you guys are cool with this. So I want the mean to be caught by this interval. All right. This notation I'm using is not perfect. It's more the idea that I'm trying to use with this for the moment. Okay. So this is kind of a weird, interesting mathematical process we're going through. We have a concept we're working with. So it's not really well-defined symbols for mean caught by, but the mean is approximated by this interval is the best math that I can capture that with. Stay with me now. Stay with me. Now. What is that the mean of? Because of the symbol? What kind of mean is this? Instead of this? Huh?
Population mean.
Population. I love it. Now, you're gonna love this. So this is the percentage of a population. This is the percentage failures. This is the percentage successes of a population. What I need, though, is I need this idea. So what would X bar be? Well, here's the formula we use. Here's the symbol I use for percentage from a sample. Oh, you're going to love this. Oh, you're going to love this so much. That's called P hat. Yes, you got it right. It's the party hat. It's the hat you don't want to wear. The P hat. P hat. Have fun with that.
Just South Park references all day.
Oh boy. All right. And then this would be the square root of n p hat q hat. I don't know how you guys feel about that. So it's a lot like.
What does the E mean? That's air.
Oh, I'm sorry. No. Do you think that's an E? Is that what it is?
What is that? Is that a sigma?
No. You should know. It's a Q, right? Q's and P's go together.
What does the Q stand for? Sorry.
What does a P stand for? No, stop. What does a P stand for? Let's start there.
Population?
No. Population. What was this when we first learned about binomial stuff? This is the probability of
Success.
So this, of course, is the probability of
Failure.
failure, of course, yes. So what we're trying to work towards is if I take a sample of people and I find that 57% of that sample will vote for candidate A, I want to create a confidence interval for the percentage of the whole population that would vote for candidate A. Are you with me? Wouldn't candidate A want to know that? Like, give me an estimate of how many people look like it's going to vote for me. Well, I make a confidence interval for this person, and that would tell them how to feel, pretty much. Are you guys at all with me?
Yes, kind of.
Okay, one person partially.
The sample was a version was this, is it a lowercase sigma? Or
Just what
sorry,
is
for the
hat?
NPQ. The symbol, okay, yeah.
Like it's
S.
equivalent to the sample standard.
Is it bar mitzvah?
Say again, sorry.
What does the hat signify?
Okay, somebody help me out. What does the hat signify? So what does this symbol mean?
The population.
Population mean. What does this symbol mean?
Sample.
So this goes with this, meaning that must be a percentage of a population, right? The probability of success for a population. So this must be the probability of success for a sample. I love it. I like it. So if I get a percentage from a sample that I've taken, that gets the p hat notation. Okay, I love you guys. I really, you're never gonna have to do any of this shit right here, right? We're working our way towards another formula like this. This is all just going towards that direction. Okay. So let's see what we can do. Let's replace things here in terms of percentages now. So I want to capture this. That's captured, right? I want to capture this. That's captured by this, give or take z times this.
Holy shit.
All I did was replace, and then this idea is replaced here. That's all I did. We already identified all the parts to this, right? And again, this is nothing you have to do yourself. This is the weird shit. This is the shit that took years for somebody to figure out a nice way to represent this stuff. Now, what sucks with this so far is this is not a percentage, right? N times that is not a percentage. You guys with me? That would be an expected number, right? So I have to divide everything by n. So how do I capture the real population percentage? By doing this formula p hat plus or minus z. Now, I'm almost certain I've completely lost you guys, but that's all right. Just come back to me. We're almost there.
What's N stand for? And it's redundant.
Somebody help him out. What does N stand for?
Number in the population.
It always means the same thing. Careful. It just means the number in the group we're looking at. It could be a sample of population. So N is the number of things. Number of people, number of dogs, number of whatevers.
I'm just making a huge key right now.
Sure. That's what it always is. Can I cancel these N's?
No.
No, good. So what can I do? Is there anything I can do?
You can
What?
cancel the first and
Sure. That's easy. What can I do here? Can I do anything here? Why can't I cancel these ends?
Because it's under the square root.
One of them is under a square root and the other one isn't. Do you guys, does anyone, sorry?
You could square it.
I can't because it's a part of a longer thing. I'd have to square the whole thing and that would get really gross. So what I do instead is, what's equivalent to n? N is the square root of what? N is the square root of n squared. Does anyone agree with me? What's the square root of n squared?
n.
N, right?
So you can just put the whole thing under the square root.
And I can kill one of the n's. So now, like you said, I get one big ass square root, but now one n cancels. So I get p hat, q hat over n. So that is all you really have to worry about. That's the formula for making a confidence interval for a percentage. All right, so I know I like to torture you. I do. I take you through all the insanity, right? I understand. You're not going to have to redo this at some point yourself, right? We can just now build off of this. So let's do a concrete example that uses this, dear God, please, Jeff.
Wait, before you move on, can you just really quick explain the whole n canceling out thing that you just did one more time?
All right, so let me just focus just on that piece.
Like replay 30 seconds ago.
Say P is approximately equal to P hat plus minus Z root N P hat E hat over root N.
This is a Q. There's no N up here.
Oh, sorry. N.
So, like somebody, is this cool? Could I just put this one big ass square root? Because isn't everything being square rooted? So let me just write one big ass square root. Is that cool?
Yeah.
Yep.
And then can't I cancel one? Isn't this two n's down here and one n? So doesn't one of them cancel?
Yep.
Yes. So then you get there. P hat Q hat over n.
Oh, okay.
Cool.
Yeah, I zoned out for 2 seconds. By the time I zoned back in, I was totally lost.
That's all it takes. All right. So let's do a concrete. Sorry.
Don't erase that. No, it's all gone.
It's still there. I don't understand. It's all still there.
So this is the formula for the probability interval. Is that what I'm talking?
If I want to create a confidence interval for a mean, I could use that formula. If I want to create a confidence interval for a percentage, I've got to use this formula. So what I want you guys to realize is, for this kind of problem, are they going to tell me a standard deviation? You guys see a place for a standard deviation here?
No.
They only have to tell me P hat and N. Do you guys see that? Because what if P hat is 0.71? What is Q hat?
1 minus.
Probability of failure.
Yeah. So no matter what clothing they're wearing, P and Q have to add to be 1. Now don't worry, there's not a P sock and whatever left. It's just P hat. We stop with that. There's no more. We don't put P trousers and whatever. Don't worry. That's the only piece of clothing we put on them is a hat that you know of. Now, so here's a problem we could have. We survey 128 people, and 11 of them say they like statistics. I'm gonna cry. Find the something. All right. Don't worry. We're gonna find the 90% confidence interval for the true percentage who like stats. Before we can do this problem, can somebody help me? There's one little thing I have to talk about now that's going to be a little bit weird. You're like, okay, good Lord. If he's saying it's weird, it's going to be freaking weird as shit. But before we could do most problems in this class, what do we need to know? What is it that for most of the problems we have to know first before we can do something?
Population
No.
or sample.
Not a number, not a thing, but I got to know the distribution is normal. So for many of the problems, and in this case, don't I want to look up the z-score and the z-score chart to figure out, for 90%? Don't I need to look it up?
Mhm.
I cannot do that until what? I know that the distribution is normal. That's the only time the z-score chart works. So, oh man, we need to take a little detour. I don't know how you want to go to a different page. Here we go, and then we'll come back to this. I know. You guys will be all right. So before we can even do this problem, what time is it? Okay. Here, we'll do this, and then we'll take a break. So I'll give you a little light at the end of one of our tunnels. I'm back here. Let me erase you. You might just want to watch this. I don't know. This is an idea. It's all right. I really want you guys to get ready for this. If I have to make a means confidence interval, don't I need n greater than 30? You guys agree with me? Wouldn't I need n greater than 30? That's the check I would make. Unless it just says it's normal. I need n to be greater than 30. Everybody cool?
Oh, it's 35.
No, it's 30. You said that earlier too. Now, if I want to make an interval for percentage, it isn't just this. There's something more to it. So that's all we're doing right now is if this doesn't tell me it's normal, what will in this situation? Okay. Oh, geez. Stay with me. Come on. This is some cool shit. It really is. I just sense you guys going, oh, God, I'm just going to walk away for a while. Stay with me. This is so cool. We'll see if you guys agree. Just help me out. If I had 14 things and P was 0.5, what would the mean be? 7, 11. So does this make sense? The picture would look something like this. I'm not going to do it all. So it'd be 0, 1, 2, 3, 4, 5, 6, 7, and then it would go down from there. Do you guys agree with me? The mean should be about where the highest peak is. You guys with me? That's the expected value. That should be where the highest peak is. Yes? Maybe? Does this look normal?
Yes.
Does this look a little bit like Asgard, the castle? Yes, it does. But that's just an aside. Sorry if you don't even know what that is. I understand. What if, so this looks normal, right? This looks normal. What if I have n is 14, but p is 0.1? What would mu be then? N is 14, but p is 0.1. What would the mean be?
1.4.
1.4. So now the highest peak is going to be like around 1. And then it's going to go down from there. Does that look normal?
No.
No.
Skewed to the left.
Yeah. So can you guys understand then that where's the mean got to be? Doesn't have to be in the middle, sort of. Doesn't have to be far enough over. See, the problem here was the mean was too close to the side, so there's no room for it to go up. If I put it in the middle, it's got room to go up. It's got room to come down. Yes, maybe? Yes?
Yes.
So watch. This is NP. NP has to be at least 5. You see how we got 7 here? Which is greater than 5, which means it's going to look normal. This side, to make sure you're not against that wall, is NQ. And NQ has to be at least 5. So as long as these two things are true, that puts the tallest peak in the middle somewhere. So it's got room to go up, room to come down. So instead of checking this, like I do for means,
how did you get 5?
The same place it got 30. How's that sound? right? If you were not too concerned about 30, you're not too concerned about 5. It's just we noticed that in a lot of different simulations, as long as it was at least 5, no matter how weird it started, it became normal, which is very much where we got the number 30 from.
So both sides have to be like the same number? Is that what you're saying?
No, they don't have to be the same number. They just have to be at least 5. So NP could be 18 million and NQ could be 5.3.
Gotcha.
And then you're good. Because that just means it's in the middle for the tallest peak, which is where it should be for a normal curve. It actually makes sense. It actually makes sense. Okay.
Wait, I'm sorry.
That's fine.
This is 5. Like for 30, it was like the sample size. What is 5?
5 would be, in this case, the number of successes expected and the number of failures expected. But
So I'm thinking 50-50, but it's
no.
Because does that?
However you want to try to memorize it, that's cool. But it's not quite as immediate. So it kind of makes sense that I have to take N into account and P into account and make sure they're both together at least something. Whereas this one doesn't have any percentages. So it's just N. Maybe. So, all right, you guys ready? I'm going to flip this. And then I want to do one thing. We'll take a break. We'll finish this problem out. Here we go. All right, just do it. So real quick, is this problem normal? Somebody help me out. I need to figure out N P hat and N Q hat. Can anybody figure out what the shit P hat is? Remember, all P hat means is the percentage from the sample. Go ahead.
Is it 11 over out of 128?
Kick ass. And what is that? Sorry.
How many decimal places?
Oh, all right. So
0.
I love it. This goes back to normal stuff. It's at least 3 decimal places for percentages.
So 0.086.
Say again, sorry?
0.086.
0.86. So then what would Q hat be?
0.914.
Good, 914. So then you can check N P hat, N Q hat. Now I want you guys to do this, and then I want to point out a shortcut. What is N in this problem, by the way?
128.
Yeah, 128. Good. So do 128 times 0.086, and I'll bet you that you get 11.
11, yes.
Of course you do, because where did 0.086 come from? Didn't it come from 11 divided by 128? So then what's 128 times this? It's freaking 11. So there's a shortcut in there for you to see if you don't, just do this shit and you get 11 something or 10 point something or whatever. And that's at least 5, yes, check. And then what's NQ hat? I'll tell you, it's going to be 117 roughly, because that's the rest. If 11 successes, there must be 117 failures. Can somebody check me out? Is that roughly 117?
Mm-hmm.
If you do 128 times 0.914, do you get 117? I pushed you too far. We need to take a break.
Yeah.
But real quick, since I got these two at least 5, that means this is normal enough, which means I can go ahead and do this, and that's what we'll do next. But let's take a break. We've been going at it for a while. I'll leave that up there. I got to turn on my AC. So go take a break. Let me know if you have any questions right now. I'm going to turn my AC on real quick. Hello, everybody. Come back. Where are you? All right, guys. So let's do this. Oh, wait. We got to do the one on the board first. Okay. Do we finish it? One on the board. So, all right, so let's do this. This is good stuff here. Just to remind you guys, this is the equivalent of n greater than 30. So what we did here was we saw that n p hat is at least 5. and NQ hat is at least 5, so that means it's normal enough. Normal enough for what? Normal enough to use the chart. Okay. So I'm going to erase that over there, so I've got some room for this work. Put up at the top the formula. Holy shit. Shoot. So again, this happens so often. The idea was painful. I think you guys might agree with me. The whole time it took to get to this equation was painful. Now we're here. Now it's just plug and chug. Put the right stuff in the right place, because that's why this was so hard, because now everything else is easy after it relatively. So I know what P hat is, right? I know what Q hat is, and I need those in the formula. I know what N is, right? So of course, like always, what's the only thing left that I don't know yet in the formula?
Z-score.
The Z-score. And who remembers, or who can look up real quick what the Z-score is for 90%?
1.645.
Yes. So I just throw everything in there. P hat is 0.086, give or take 1.645 of these. 0.086 times Q hat 0.914 divided by 128. The biggest mistake people make is putting this in the calculator incorrectly. Make sure that all of this is in the square root. So some of you guys have a calculator. When you do a square root, the square root grows. Does anyone know what I'm talking about? Square root grows. If you have a calculator where you hit the square root button and it does this, and the square root doesn't grow any bigger, do not close that parenthesis until you get all that stuff in here, or else you're not in the square root anymore. So let's all take a minute and see if we can get the correct error. Where's my, oh, how come on later? All right, let's see if anybody wants to be brave enough to tell me what you got.
I got 0.0407.
Yeah.
Yeah.
0407?
08.
Yeah, thank you. Is anybody else having trouble? Anybody else get that or not get that? Just for this piece, right? Just for this piece. That's the error. So it's 086, give or take this much.
Possibly explain it or do it?
Say again, sir?
Could you possibly explain it or do it? I kind of struggled a little bit with it. I couldn't.
All right.
I think I plugged it in wrong.
All right, hold on. Unfortunately, my hold on, everybody. Just gotta go old tech here. Hold on, give it a minute. Come on, focus. Hold on, sorry. Focus. All right, what? Oh, hold on, everybody. Hold on. I don't know why it won't focus. There we go. Maybe this will work. Yay. Do you see that last line? So I have a calculator where the square root grows, right? Is that cool? Do you see that? Now, let me see. Let me see. Hold on. Let me see if I can emulate an older calculator. Yes. All right. So, oh God, look at me. Okay, sir. Let me put this in here. as if it's one of the old calculators. So see, here's the beginnings of this with an older calculator. Look at my battery, that's not good. See how the square root button, the square root's not gonna grow. So what I wanna do then is put 0.086 times 0.914 divided by 128 and then put a parenthesis at the end. Everything in the parentheses are in the square root then. Are you guys with me out there? So now if I hit enter, I still get the same answer. Yay! Is that okay? Change that back before I forget.
So we are 90% confident that.
Hold on. Let me catch up now.
Yeah, I got it. Thank you.
Sure. All right. Before any statement, what's the interval?
It's between 0.0452 and 0.1268.
Yes. Cool. Go, Jeff. All right. So then we are
90% confident that
excuse me.
between 5% and 13% of people like statistics.
That's up at the interval. Yeah, sure. 4.5% to 12.68%. So it looks like a 14. Right, we're 90% confident that the interval, make these into percentages that acts like the units. You always need units, and if you change the percentage, that's the units. This percent, that percent. What if, so that the interval does what? At this interval, blah, 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 blah.
Contains the population mean.
Careful, the population what?
Mean.
No.
Percent?
It's your percentage.
Percentages, right? Contains population percent of people who like stats. Purposefully wrote so tiny and so much glare and so much everything sucks, and I'm sorry. Let's do that. Oh, I know what I can do. Hold on. There we go. And does that do anything? It's a little better. Okay. Somebody's chatting at me. Can I screenshot real quick? Of course. And of course, all this is being recorded, so you could either way or both. I'm really dark here. Okay. So, all right, I know this is all relatively new, but didn't that sort of feel exactly like the other confidence interval we did? All confidence intervals fundamentally are the same kind of work, right? What was sucky today was the derivation of that formula, which is what we should expect. It should be a little hard to derive a formula that works for any situation. That should be kind of hard. And that's why, I don't know if anyone agrees with me, that was relatively easy. Because we put all the work into making this thing. Can I point in the right direction? Yes. So, if you look at the other side of that dolphin handout, there is an example from section A3. Some of you guys, we'll see if anybody can notice how I was a little evil on this problem. Doesn't it feel like I don't give you enough information? Anybody? Do I give you like a lot of information?
Mm-hmm.
I do? Okay, cool. I like it. Some people are like, you one sentence, and then you ask us. Like, that's all I need to give you, right? I don't have to give you much of anything. What's P hat?
459.
Divided by?
2.
Good. So what do you get?
0.703 or is 0.704.
704. Okay. All right. And then of course Q hat is going to be
296.
296. I like it. And what is N?
652.
Holy crap. Sorry, I think I heard it.
652.
Yeah, 652. I like it. Be really careful. People use that one that sucks. It's going to throw everything off, but you're only going to lose a little bit of points. But N is the total number of people or things you're looking at. What does this mean?
You're checking to see if it's a normal distribution or not.
Exactly. I like it. I always want somebody to say, I don't know, you're the one who made the damn sheet, Jeff, if you don't know. Yeah, but this is just that N greater than 30 step, but we can't use that because that's for means. I need the thing that works for percentages, which is N. Now, let's see if anybody, does anyone understand this shortcut? NP hat is 459. Of course it is, because what is N times P hat is that equal to the number of things? Isn't N times P hat going to be 459? If you don't trust me, you can just do 0.704 times 652, and you're going to get something that would round to 459. Why don't you get exactly 459? Because didn't we round this? So of course the answer is going to be off from what it's supposed to be. And then NQ hat is the rest, which will be 193, I believe, right?
Yeah.
Yes. Cool. And of course, those are both at least who? At least what? Well, all right. That 5. I was just waiting. 5, right? 5. It's got to be at least 5. Like, and you're all like, oh, come on, Jeff. Another thing to memorize? Yeah. Yeah. Now, what's a little evil, of course, about the z-score? It's a tiny bit evil.
We can't use the shortcut.
Yeah. So you just got to do it the long way. So take a minute and figure out what the z-score is that I'm going to need to use here. Who remembers what it was for 95% confident? Is anyone worried that they actually remember some of these numbers?
1.96.
1.96. So if 96% confidence should be a little bit bigger than 1.96. Just a little bit.
I got 2.05.
2.05, exactly. Just a little bigger. Doesn't that make sense? 95 is 1.96, so 96 should be just a little bit further out. How'd you get 2.05? What'd you do?
I looked for 0.02.
Good. 96 inside means there's 02 outside. So if you look that up, you'll get the 205. Please let me know if you're not sure what's happening. All right. And now it's just plug and chug. So go ahead and plug in what we know into the formula here. These things always look like eyebrows to me, but oh well. Little hats. It's like the P and Q is looking at us like, what? What?
That looks like a yarmulke.
Oh, okay. Even better.
They're bar mitzvah.
P and Q are having a bar mitzvah. Yeah, exactly. Mazel tov. Dadgummit. All right, so let me know if anybody.
296 or 295.
Tell me what the error is first.
0.03.
Oh, I'm sorry. You're asking me about, I'm sorry, Billy. I thought you were telling me an answer. This is 296 for sure. I just couldn't make a 6. That's not important for a job as a math teacher, right? Not being able to make a 6? Is that bad? Sorry, go ahead. What'd you get for the error?
0.0367.
Well, it'll be 6.6 if you want to go. Yeah, because the next
yeah.
number is 4, right?
Oh yeah, I'm wrong. Sorry.
You're fine. And then you just have to add and subtract that. So this is that, by the way, I want to point out, that's that plus or minus 4%. If I round that to a whole percentage, do you guys understand what I'm saying? That's the plus or minus 4% that we see at the bottom of statistical analyses. I'm going to say 42% of people want to vote for this, and at the bottom it says plus or minus 4%. Well, that's where it came from, right? And you're all like, I could have lived my whole life and never known where that came from, and I would have been fine. Well, too bad for you. Now you do. You know where it came from. All right. So what is this interval?
-6.674.
All right. Up to point.
Oh, 3.
You can round it to 3 places now. That's fine. So take a second and see if you can do the conclusion. We are farmers. So how's this go? We are 96% confident that what?
The interval.
.67%.
66.7% to
74.1%.
good. Contains the true something or other. I forgot what this is all about. The true
Percent?
Yeah, percent of voters who voted in the last election. Cool. Okay, I like it. It's much more informative to tell somebody this than it is just to tell them, where do you go? This, 70.4%. It's better to say, here's my 96% confidence interval for the percentage. It just communicates a lot of stuff very quickly. Now this, do you guys remember doing this kind of thing just a minute ago? I'm not going to do the algebra again. It's very similar. It's just taking this and solving for n. So it accomplishes the same thing. If I want to be, so here it is. I want to be within 3%. Oh yeah, this is evil. I like this problem. So notice this is a totally different problem, right? This is number 2. It has nothing to do with this situation at all, right? So how many people would we need to survey to be within 3%? So what is that? What's that 3% going to go in for? What letter?
Air.
Yeah, and be careful. It's got to be as a true number, as a decimal. So the error is 0.03. Of the true proportion of students who pass stats the first time around at 99% confidence, what would n be? I'm sorry, what would z be? Does somebody remember?
2.575.
Yeah. Now here's the thing. So here's the formula right here. We know z, we know e. What the shit are p hat and q hat? So here's the thing. I'm not even gonna say it. You know what I was about to say. Make sense. If we don't know what the percentage is, what's our best guess? So what is your best guess for the percentage of shit? I don't know. I always go to what's your best guess for the percentage of the pets for the people next door that are dogs? So let me say they have 8 pets next door, and they're dogs and cats. What's your best guess for the percentage of the pets that are dogs?
60%.
You say 60?
Yeah, 60%
Oh.
chance that their animals are dogs.
Why is that your best guess? Or is that just a guess and you're like, well, that's the best I could do?
Just a guess.
I see. I'm with you. The best guess would be 50%. Half and half. I have no idea if it's more than half, less than half, so my best guess is 50. Stay with me. No, stay with me. This is freaky. So the whole purpose of this problem is to figure out how large of a sample I must take so that my error gets down to 3%, right? What do you think if there's something I don't know? Should I have to take more people to cover my ass for not knowing that, or should I have to take less people?
More people.
I should have to take more people. In statistics, when you don't know something, you have to be penalized for it, right? So now listen, mathematically, if I make p hat 0.5, and of course, what does that mean for q hat? What's q hat got to be then?
0.5.
0.5. If I make them both 0.5, mathematically, that makes n the biggest it could be. So if I don't know what these are, but I want to figure out how big of a sample I'm going to need, I guess 50-50 for 2 reasons. It's my best guess, and mathematically, it makes n come out the biggest. That's my punishment for not knowing shit, right? So let's throw some stuff in here. N equals z squared, right? Just using this formula up here that I've circled about 3 times too many times, times p hat times q hat divided by e squared.
P and Q always add up to equal 1, don't they?
That's right.
So then how could changing what they are affect the size of n?
I'm not adding.
What is 0.5 times 0.5?
1.
No, not adding, multiplying. What is 0.5 times 0.5? What's a half times a half?
0.25.
0.25, a quarter, right? Now, in your calculator, what is 0.6 times 0.4, which also adds up to 1, right?
So it's based on the multiplication, but they always add up to 1. Got it.
They add up to 1, but how do you make the product the biggest? You make each of them 0.5. Anything else, and it will multiply to be less. In fact, what if P was 100%? What would Q be?
0.
0.
And what's P times Q then?
0.
Freaking 0, right? So it kind of makes sense that the midpoint makes it the tallest, 50-50. Makes it the most. All right. So what do you guys get when you do all this weird shit here? Let's see.
I got 715.
All right. I like it. And of course, we're talking about, whoa.
Wait, I forgot to square it. Sorry.
Yeah. Careful now. You only square these, right? Be really careful. There's so many ways to get parts of this.
How come you don't square the p hat and the q?
All right, if you want me to. Now, I love algebra, so if you want me to, very quickly show you the derivation. I could multiply by square root of n and divide by e, right? Are you with me? So I can just change this. Is that cool? And then I could square both sides. right? So then the z gets squared and the e gets squared, but what happens with this?
Oh, okay.
Yeah, because
That
it's in the
gets
square root.
released.
Yeah. Okay. So what do you guys get for n? I think somebody somebody said something about that.
1841.
Sounds like a history test. Point something.
0.84.
It doesn't even matter what it is. So I'm talking about people. I don't want any of you to become Dexter running around chopping people up. So please round up and take whole parts of people. Not whole parts of people. Strike them. Take entire people. That still sounds bad, but too bad. We'll have Liam Neeson coming after us. The particular set of skills. Okay.
I have a particular set of skills.
All right. So I would have to take a sample of 1,842 to guarantee that I'm within 3%. Now, has anybody ever heard the phrase preliminary study? And not just because you read the next part of the question, right? I mean, outside of this class, have you ever heard of the phrase preliminary? So one reason sorry?
I would say, don't they use preliminary studies when they test medicine before they give it out to people?
Totally. So there's multiple reasons to have a preliminary study, but one reason would be this: to get a more precise estimate of the sample size needed to be within something. So up here, didn't we have to guess what they were? P hat and Q hat? But if I do a little tiny preliminary study, it makes me sound drunk. I might be drunk. Don't I now know what P hat and Q hat are? What's P hat? How do I figure that out?
31
out of 42. I like it. Where's your something?
0.738.
What is it, sorry?
738.
38. So then Q hat would be
0.262.
I like it, 262. So now it's the exact same formula. Exact same formula. I'm just not guessing. Now I know P hat is this, and I know Q hat is this. And let's see what we get for the required sample size. My claim is it'll be smaller. It'll be less stuff.
Yeah.
Shit. If I could just type. Oh, that doesn't look right, Jeff. What did you do, buddy? Oh, I see what I did. Oh my God. I tried to do this. I tried to do a shortcut and I did the completely wrong thing. All right. Yeah, okay, that's better. So what do you guys get? Is it a little bit less than we need? 1424 point stuff, so 1425. That might not seem like that much less, but that's 400. That's over 400 fewer that I need in my sample now, just because I did a little preliminary study. Preliminary. So it's like the judicial system. All right. I say we stop now. What do you guys think?
Can you go back down?
I can't. I am right now. There I am. Sorry.
I'm just copying the entire thing in my notes.
You're fine. I say we end class. But don't forget what's happening Monday.
Test.
Test. The quiz. And the practice quiz and the solutions video has been up on Canvas for a little while, so you can look at that. We have a quiz on chapter 6 and chapter 7 on Monday. That is like the beginning of the z-score chart stuff, and then the central limit theorem stuff. Right? That quiz is on Monday. Okay.
Can you post the your answer sheet to the CLT practice sheet?
Oh, yeah, as always, shoot me an email.
Okay, thank you.
Because believe it or not, between you asking me and me signing off, I will have forgotten.
I get it.
Not out of any evil intent. Let's see, do I already have this thing saved? So I just have to do this. Pop. All right. So I can certainly do that. Oh, you know something? Did I put it? No, I guess not. That was the solutions. Oh yeah, for the practice quiz. I got those up there. Okay.
Was this 8.2 and 8.3 today?
This was 8.3.
Okay, so we haven't done
this,
8.2 yet.
This sheet is 8.1 and 8.3. And again, the reason I don't do 8.2 is because it's going to introduce a new chart. 8.3 still use the z-score chart. That's why I like to do that next. 8.2 is going to introduce a new chart. Yay! And it's going to go along with our last. I told you there are 3 confidence interval formulas, so we have 1 left. And it's going to have something in the place of the z-score. It's going to be a different letter to go with the new chart. And that all sounds so fun, Jeff. Thank you so much. Okay.
Okay.
You guys can head out now if you want to. You know, you guys have a good weekend. And I'll try to catch up with grading over the weekend.
Thanks, Jeff.
You're welcome.
Can I bother you with another homework question?
Yes.
I'm still looking at section 8.1 and I'm looking at number 9. I didn't know if you still wanted us to do the statement, but I was wondering how I would word that statement. So I put, we are 90% confident that the interval 7.944 minutes to 8.456 minutes contains the true population mean time.
Yes.
For
Mean time to complete the yeah.
Oh, would I say for people to complete the form or just mean time to complete the form?
Yeah, it's understood that it's the mean of people, you know, but you can put people in there. But if you don't, we know that you don't mean snakes or something.
Okay, perfect. Thank you.
You're welcome. How's everybody else? You guys okay? I'm gonna head out. So I'm tired. If nobody has any questions, okay, I'm out of here. Oh, Billy, what's up?
I'm on homework 7.1, 63 still. D, I answered yes, because if it is a normal distribution, the mean remains constant.
Wait a minute, 63?
Yeah.
So D is not a yes or no question. Oh, I see. I'm sorry. It is a yes or no question, but it requires work. You don't know if you would be surprised until you know the probability of it happening. Right?
Okay.
You don't inherently know the probability of this happening. So you have to set up the, you know, they want to know the probability X bar is greater than 12. You got to set up the picture. You got to use the correct standard deviation, right? You want to use the new one because you're talking about a sample here, right? And then part E is going to be the same work, just with the original standard deviation to find your z-score, because part E is about one person, not a group of people, right?
Yes.
Thank you, Professor. Have a good weekend.
You too. Thank you. Just got 2.
Thank you, Professor. Have a good weekend.
Oh yeah, you too.
All right, I'll be in tutoring tomorrow.
Okay.
I'm not giving up. You're not getting me out of this class no matter how hard you try.
All right, I haven't even tried, but okay.
I'm just kidding.
You would know if I was trying. Take care of it. Are you guys, everybody else okay? I'm gonna head out. Bye, everybody.